And welcome everybody to the Daily Space Weather Show. We've got a massive uptick in solar activity continuing as we get closer and closer to solar maximum. That's the past 24 hours from SDO 304 angstroms, some spectacular CMEs to cover today, an increase in the radio flux, an increase in the sunspot number, and an increase in spectacular imagery. So here we've zoomed into the equator and we've moved the 304 angstroms to the 60-minute running difference and added 171 angstroms. We're going to take a quick tour here, starting with the northern sector. These are all 24-hour videos. And here's the North Polar region. You'll see a bunch of active filamentary activities happening there, also some bright spots. Those are active regions, some of which are sunspots. Lots of stuff going on there. I won't try to explain it. Some hider flares there, just south of the Earth scale. That's the brightening you see down toward the surface as plasma succumbs to gravity. Here's a great look at the polar region. We did see some crown prominentiary activity up there, so decided to show a close-up of that. Next, we'll move down to the northeastern limb. We've got more sunspots about to rise here, folks. So you ain't seen nothing yet. If you thought we're already at solar maximum, or we've already gone past solar maximum, think again. We're anticipating that to be in September or October of 2024. Here's the northwestern limb. And yeah, nice. And that sunspot that has recently set there still does have the capability of producing large flares, but that is waning promptly here. So within the next about 6 to 8 hours, that is becoming very unlikely to produce a large flare. However, there still is a flare watch in effect. So here's the just south of the equator on the western limb. We've got multiple regions that are capable of producing large solar flare activity. Here's the northeastern limb, a close-up of that. Towering filaments. And here is the full southern hemisphere. How you like them apples? Pretty sweet, right? Next, we'll take a look at sunspots. And sunspot number here above 180 today. So a big increase in sunspot number from yesterday, and you can expect that to possibly continue to rise here. It all depends on evolution and which sunspots rise versus which sunspots set. Here's colorized magnetogram for today, January 11th, 2024. And next we'll take a brief look at volcanoes. These are the erupting issues. There have been some alert levels changed. Subanose-jima continues to explode. Same with Luotobi, although it has simmered down a little bit, still producing an 8,000-foot plume of volcanic ash. Also Strombolian and effusive explosive activity happening there at Merapi. Not Merapi, Luotobi. Semaru also producing a 15,000-foot ash plume. There's Merapi, which has had its alert level raised from level 2 to level 3. Siaga. The Trident volcano has been downgraded. That's in the Aleutian Islands. So that one is, the Alaskan Peninsula. That one's been downgraded to green as seismic activity has largely ceased. Popocatépetl continues to explode. Santiaguito exploding. Fuego, Revenador, and Sabancaya. That's the volcano rundown. Let's get to earthquakes next. First, the past 90 days. There's a convenient bar graph for you for the past 90 days. Largest quake of the past 24 was a deep quake at Afghanistan. Here's the location of it. Located in some rather high mountains there. Those are like 16,500 foot peaks right there. And it was at depth, at over 200 kilometers estimated depth, so not likely to have done much damage. There's a location of that. It's a 6.4 magnitude quake. We'll get to it here. We'll call out quakes of a 5 and greater magnitude. Mariana Islands had a 5.0 at 22:44 yesterday evening. Peru had a 5.0. That was also at depth, over 115 kilometers estimated depth. South Pacific Ocean had a 5.2. In the middle of nowhere, folks. The 6.4 in Afghanistan occurred at 9:24 this morning. Again, it was at 206 kilometers estimated depth. And then a lull in 5 and greater magnitude activity, which continues until the making of this video. So, here's some more imagery of the closest star. That's another 24-hour video. Now we've put 304 angstroms running difference of 60 minutes along with 193 angstroms raw footage. And let's get to some stats. Space weather stats are next. The 10.7 centimeter radio flux now up to 193, folks. 193 is the new radio flux number. There it is in a 1-year graph represented by the black line, the red line sunspot number. And yeah, solar maximum, it's on the way. Expected to show up in September or October of 2024. Space weather enthusiast dashboard not forecasting any geomagnetic storms or geomagnetic unrest. So let's take a look at Earth's magnetic moment from space, shall we? That's a rhetorical question, by the way. This is a space weather dictatorship. And remember, folks, a benevolent king is superior to a malevolent, democratically elected official. That's the past 4 hours of Earth's magnetic moment from space depicting magnetohydrodynamic pressure, and it is geomagnetically calm as we have a slow and low solar wind. Here's Earth's magnetic moment from the ground for the past 4 hours. Our geospace ground magnetic perturbations map depicts magnetic flux density at ground level. If you want to read about how the Space Weather Modeling Framework generates these models, click on the Details tab from the page. It'll link you to the Space Weather Modeling Framework. You can read about all the variables and even download the software used. KP index currently at 1. KP1 is the planetary K index. And let's move on to some solar wind data. First, the ACE, which is showing a very diffuse solar wind here, only a half a proton per cubic centimeter, but a little bit of speed has kicked up there at 457 kilometers a second. Quite a bit faster than yesterday. At the Discover, a little faster and a lot denser solar wind. So the Discover there picking up about 7.5 protons per cubic centimeter and about 500 kilometers per second. An elevated solar wind there. Looks like a bit of a coronal hole high-speed stream showing up. Here are our GOES magnetometers located at their geosynchronous near equatorial orbits, the GOES 16 and GOES 18. It's just after noon local time for the GOES 18, represented by this blue letter N. That is local noon time for the GOES 18. Next, our top view ecliptic plane field plot, as it's interesting to see what kind of magnetic sector Earth will be in here. And it looks like indeed Earth has snapped into a North Pole-oriented heliospheric sector. So we were talking about this yesterday. It's gotten a little bit more stable here as a result of that. It looks like the North Pole-oriented magnetism has won for now. And here's our line of sight field plot. This depicts the photosphere magnetism in grayscale, solar polar fields in red for south and green for north, and the solar B field in blue. The B field is the field that goes through the magnet if this magnet is the sun. So lots of information there. That's the past 4 days of our Gong 2 data from the National Solar Observatory, and now we're on the coronal hole line of sight field plot. And we've got almost entirely North Pole coronal holes, except around the North Heliographic Pole, where we've got South Pole magnetism. So that's what's going on. Let's bring up the last image here and then take a look at SDO. So there you go. There's a 24-hour video with SDO. And what do we got? So these are south. And all the rest of these are North Pole coronal holes. So that's what's going on in terms of heliosphere magnetism. That's another 24-hour video from Solar Dynamics Observatory. 211 angstroms is fantastic at showing coronal holes. Let's move to sunspots next. And like I said, the sunspot number is now at about 185. 185 sunspots is the current number. And here's our flare probability monitor and scoreboard. And we do have a very high likelihood of large solar flares in multiple locations. So first of all, you've got this western limb. That could produce a large flare. This area here could produce a large flare. And also this sunspot, 3545, is fairly magnetically complex. So multiple spots there. And of course, rising regions are always capable of producing large flares. Pretty hard to analyze the magnetism before it's risen into the Earth-facing zone. So that's what's going on with sunspots and flare probability. Let's take a look at sunspots from SDO. There's the SDO magnetogram for the past 24 hours. Not half bad. We have a bullseye-like feature down here of South Pole magnetism. A couple bullseye-like features there. So that looks like a very likely place to see a large flare, folks. It's right in the Earth-facing portion of the solar disk. So major solar flare watch in effect in various locations here. Sunspot number jumps all the way up to 185. And let's talk solar energetic particles and flares. Proton flux at baseline levels. No spikes. X-ray flux, well, the background flux has now moved all the way up to about a C2.5 or so. At least a C2. The average X-ray flux is probably more like a C6. Well, maybe a C4. Anyway, X-ray flux has come up quite a bit, and 1, 2, 3, at least 4 M-class flares in the past 24 hours. Let's take a look at those. There is SDO 94 angstroms. And the most active region is indeed that western limb. So, eyes on that western limb, it may be the source of additional large solar flares. And let's get to a star chart next. This is what's going on overhead Lehigh Valley. If you want to make your own star chart, skyandtelescope.org is a good place. And today we're showing the northern sky there, the area around the Big Dipper, north of Polaris. And we'll show you why here in a minute. First, a solar system forecast. That's where things are today on the 11th. New moon coming tomorrow, actually tonight. So happy new moon, folks. That's where things will be in a week on the 18th. And let's get to the astronomy photo of the day. The astronomy photo of the day is the quadrantids. Yeah, the quadrantids. You got to have them. Or not. I don't know. That looks like it's Korean, if I had to guess. Maybe Vietnamese. I don't know. I think it's Korean. And there are some quadrantids. There's the full view. I believe this star over here is actually Polaris. And, yeah, the 2024 quadrantids there. Believed to be caused by a 2003 asteroid. They are a relatively modern meteor shower. And there are some meteors for your viewing pleasure. The 2024 quadrantids, apod.nasa.gov if you want to look at it yourself. And let's get to coronal mass ejections. Yes, CMEs. We had some pretty spectacular ones. Let's see what's up with it. Here are today's CMEs. And let's see, that's 82 frames. So there's one out of the southeast, one out of the north-northeast. There looks like there was a large event on the far side of the sun as well. Do I think those CMEs are earthly directed? Well, the answer is no. So here we've put C2 and C3 together. Yep. Sorry to all you Aurora chasers. I don't think those are any earthly directed components, once again. So let's take a look at our custom CMEs. There's a 24-hour video. I don't know why we failed to have the C2 in there. We should have the C2 coronagraph in red for some reason. I failed. So leave some hate comments in the comment section if you're mad about it. But there's no turning back. It's onward and upward. There we go. There's the C2. We've also got the 304 angstroms difference imagery and the 193 angstroms raw imagery. So you'll see the main event was from this CME right here. And yeah, I don't think it's earthly directed. Also, there's another event over here, it looks like, also not containing earthly directed components. If you disagree, let us know in the comments, as we encourage all rage comments on the channel. Anyway, before we get to filaments, let's take a look at, once again, the full disk in 193 angstroms plus 304 angstroms 60-minute running difference. If you're wondering what my favorite spot for a large solar flare is, number 1 is here, number 2 is here, and number 3 is down here. So that's the podium of most likely spots for a solar flare in that order. I think the western limb is most likely, central disk is second most likely, and the southeast is third most likely. Let's get to filaments. There are plasma filaments. And let's switch to the colored version of that. That's Cerro Tololo, Chile's ground-based hydrogen alpha telescope. And there's the colored version. Not too bad, and you can expect things to get more and more exciting throughout most of the year. Expect the continued uptick in coronal holes, sunspots, CMEs, solar flares, etc. It's a space weather jamboree for 2024. Last feature before bonus features is the last couple of hours here from the GOES 16 SUVI. And like I said, we've got multiple spots of plasma instability over here in the west. This sunspot, just the magnetic fields are extremely complex. And then we do have an active region rising here that might be a flare producer. So that's what's going on. And let's get to bonus features. So the first bonus feature is satellite charging hazards. We don't have any. It's smooth sailing for satellites. No high energy electrons building up inside a spacecraft. No low energy electrons building up on spacecraft. GOES electron flux remains pretty low here. It's been an ongoing electron shortage. Check it out, folks. Low electron flux here for an extended period of time. That's the past year from solon.info/solar if you want to go monitor that yourself. Here's NOAA's forecast. NOAA expecting a precipitous dip there in the electron flux. Not sure why, but yeah, I don't see any CMEs striking, so maybe that's the sort of the underhanded forecast for a CME impact. I don't know. The electron flux becomes anomalous, and that's why we see these huge dips. The electron flux doesn't actually dip during a CME, but the entire ionosphere puffs up, which gives us anomalous readings, if you're wondering why the electron flux always dips during a coronal mass ejection or coronal hole high-speed stream impact. So let's also show the layer where it's measured, the F layer of the ionosphere. It's at about 300 kilometers of altitude, and here it is in vibrational frequency, courtesy of the Australian Government Bureau Meteorology. And nothing out of the ordinary happening up there whatsoever. We'll also show the difference imagery. We show it daily on the Daily Space Weather content. You never know when archiving bits of data will become useful in the future. Shout out to Scott McIntosh, who discovered Terminator events thusly. Terminator events, when the two fields cancel each other out, leading to a very high period of activity, like lots of sunspots. Anyway, before we close out the daily space weather, we'll also show the wham. When the ionosphere dies, something in your eyes shows the total electron content and radio frequencies on the right. I'm never gonna forecast again. Just kidding, I'll be forecasting once again tomorrow. Anyway, we'll close out space weather with the latest high-resolution images. There are some complex magnetic fields. These are the most. Those are beta, gamma, delta class sunspots right there. This one's also magnetically complex. So lots of stuff going on, folks. Lots of stuff going on. And some possible new active regions rising. Let's take a look at the eastern limb real quick. There's a new sunspot or two. So let us know in the comments what you think. Do you think sunspot number will be higher or lower tomorrow? We're always interested in what our viewers think, and we do read all comments, even if we are unable to respond to every single comment. Thanks to everybody who's left comments and viewed the channel. It's only the world's most comprehensive daily space weather content. No big deal. Anyway, check it out. We're showing the Arctic, the mean sea level pressure and surface winds here. Why? Because these massive high pressure zones are blocking features in the atmosphere. So these high pressure areas, other weather has to go around them. And they also push other weather around when they are able to move. But at the moment, very, very high pressure there over the Nordic countries there. So Norway, Sweden, and Finland there, seeing extremely high pressure there, 1,044 hectopascals. That is a legit anticyclone. So that shows mean sea level pressure in, that's barometric pressure in the coloration there, and in the animation is surface winds. So that's what's going on. Some major high pressure domes there. And yeah, that is a major winter feature. If you look at the jet stream, you can see the way the jet stream is. There's the jet stream, and you can see the way the jet stream is kind of all over the place. Look at the extreme bends in the jet stream over here in Europe. So the jet stream is extremely chaotic there in the North Atlantic. An upper level low right here, so lots of stuff going on. And let's take a look at wind patterns from around the world. So there are the jet streams of the east. Shout out to our viewers from this side of the planet. There are the surface winds. Shout out to our viewers from Europe, Africa, and the Middle East. There are your surface winds. Jet streams shown here. Jet streams of the west shown here. Very strong jet stream over the eastern U.S. and cold air continuing to come down from Canada. These are the surface winds of the Americas. Next, we're going to show clouds and fog for the Americas. There you go. That's a shortwave radiation map. One of the many features of the NASA GOES Interactive Weather Satellite Suite. Interested in knowing if you'll be able to see the stars or the aurora or perhaps a meteor shower? Consult the 3.9 micrometer infrared radiation map. The shortwave radiation will show you clouds and fog at nighttime. And let's just show a close-up of the U.S. here. Since we've got lots and lots and lots and lots and lots of weather warnings. Perhaps the most that we've ever covered on the channel. Crazy number of weather warnings in the U.S. We'll get to it. First, precipitation type. So there's what's happening right now. We've got multiple different modes here. We've got some rain. We've got some rain-snow mix. And we've got mostly snow at the moment. Not too surprising as we approach the middle of January, and the coldest part of the year is mid-January through mid-February. So that's not out of the ordinary there. That's something you might expect. We'll zoom out to show the full map of precipitation type. And here's our weather.gov map. And what is that? About 90% of the country there? I'll say 83% of the country there showing weather warnings. There, we've scrolled down to show you the key. Let's keep going here. That's a long key. Dag. That is a lot of warnings. Dude. Look at the number of counties lit up there, folks. If your county's lit, head to weather.gov. Weather.gov. Blizzard warnings over most of Iowa. Winter storm warnings all around the Great Lakes. And yeah, anyway, there's the map. There's the map. Deal with it. Next, pressure and precipitation forecast based on the GFS 72-hour model. Total accumulated precipitation in inches based on the GFS 72-hour model. Heaviest rains coming to Arkansas, Missouri, Illinois, and Indiana. Also Oregon, going to get plastered along with Northern California. 5 inches of rain in some areas in the forecast. There it is. Next, the total accumulated total accumulated positive snow depth change. That's a lot of precip coming. That's a lot of precip. That is over half the country being blanketed in snow just in the next 3 days. 72-hour GFS snow depth change in inches. Last but not least, the GFS temperature anomaly forecast in degrees Celsius. And look at the cold wave coming through the U.S. Some frigid air from Canada there. Going to be producing some nearly 30 degrees C below normal temperatures for this time of year. That's the GFS 72-hour temperature anomaly forecast in degrees Celsius. And then some very warm temperatures coming to the mid-Atlantic states once again. Next, lightning. That's what's been going on the past about 10 hours. Here's a real-time lightning map from lightningmaps.org. So only 19 strikes per minute, folks. It's actually a very low number of lightning strikes. Only 19 strikes per minute. Zeus, what are you doing over here, Zeus? Zeus. Okay. Anyway, Zeus is putting in some work over here. Or, if that's sacrilegious to you, maybe it's Thor. I don't know. Cheers. And Happy New Year. By the way, if you enjoy the content, why not press the like button? If you're new to the channel, why not press subscribe and get the world's most comprehensive daily space weather and most detailed solar imagery delivered right to your inbox? Check it out. Here's the largest solar flare from Solar Cycle 25 right there in our shorts. You want to see some spectacular imagery? Check out our shorts. You got friends with low attention spans? Send them our shorts. YouTube.com/smashomash/shorts. Eat my shorts, man, to quote Bart Simpson. Just kidding, folks. Don't eat them. They're made of ones and zeros, and ones and zeros can be very malnutritious. Don't consume anti-nutrients. Anyway, we'll close out today's video with the latest Doppler radar, clouds and fog, and water vapor. So there is the full 48 states. That's what's going on for vertical motion in the air column. Here's our satellite-based shortwave radiation map showing clouds and fog. And there is our water vapor map. When your Doppler radar is unclear, try the water vapor map. If you understand atmospheric physics, you'll be able to forecast your weather. Here's your recap. Ground-based systems known as U.S. Doppler radar, if they're calibrated right, they'll show you when it's going to be precipitating. Space-based systems show you clouds and fog at night, shortwave radiation emitted by those clouds and fog. Last but not least, a different spectra, 6.61 micrometers, is the water vapor map. It shows water vapor, all of it, the dry air, the moist air, and everyone in between. And I'm in between having this video continue and having this video end. So thanks for tuning into the Smash News Network, least busted name in news. I've been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back.